Hello everyone. In this video, we will learn all about hyperbola. A hyperbola is a set of points such that the absolute difference of its distances from the two fixed points is constant. Now take a look at this one. In this graph, point P here is on the hyperbola. F and G are considered as the fixed points. Now take a look as I drag this point here anywhere on the hyperbola. The distance from P to F and P to G will also vary accordingly. If I'll have this, it means PF minus PG will have the same distance even if I will move the point P here. And that is a hyperbola. Now, these are the basic parts of a hyperbola. You have here the center, you have here the two vertices, and you have here the two focus or foci. The line that connecting these points here is what we call as the major axis or the transverse axis. Then we have co-vertex 1 and co-vertex 2. The line passing through here is the minor axis or the conjugate axis. Then we also have two intersecting lines here which are considered as the asymptotes. Now take note, center to focus, let's have that as point C. Center to the vertex is point A, and center to the co-vertex is point B. Now let's have this one. Standard equation of a hyperbola with center at the point of origin. Now there are two kinds of hyperbola. It could be horizontal, in which the standard equation is this one. The other one is a vertical hyperbola, in which the standard equation is this. Now, what is the indicator whether a hyperbola defines a horizontal or vertical? 1. Now take note, if x squared is subtracted, therefore it's horizontal. If y squared is subtracted, then therefore it is vertical. Now take note, there's two intersecting lines here. It's defined, if it's horizontal, it's defined as plus and minus b over a, or that is basically rise over run. And if it is vertical, its equation would be y is equal to plus and minus a over b x. Now take note, a squared or a is center to vertex, b squared is center to co-vertex. Now how to find center to focus distance or c? To do that, c squared is equal to a squared plus b squared. Now let's have an example. Identify whether the given is vertical or horizontal. Number 1. X squared is subtracted, therefore it's horizontal. Number 2, y squared is subtracted, therefore it's vertical. And focus is located at 4, 0. 4, 0 is along the x-axis, so therefore this is horizontal. Vertex is located at 0, 7, which is along the y-axis, so therefore it's vertical. In this case, for 5, 9x squared is subtracted, therefore it's horizontal. And 6, 25y squared is subtracted, therefore it is vertical. Now, let's have this. Identify the foci, vertices, and asymptotes. In this case, x is subtracted, so therefore it is horizontal. The value for a is 4, and the value for b is square root of 20, or around 4.5. To find c, we will simply substitute here. So get the square root of 36, we will end up with 6. Now, sketching this in the Cartesian plane. Take note, it's horizontal. And the center is 0, 0. So our a is 4, so that would be 4 to the right and 4 to the left. And b is 4.5. So up and down. And the value for c is 6. So from the center, 6 to the right and 6 to the left. Next, draw the auxiliary rectangle. So this is basically a guide in sketching the asymptotes. So it's b over a, so 4.5 up, then run by 4. Okay, at this point, connect the corners here with a straight line to sketch the asymptotes. So asymptotic lines, so the graph will approach that without touching that line. So therefore, this is our graph. So with this, the coordinates of the foci, it's plus and minus 6, 0. The vertices is plus and minus 4, 0. The co-vertices is 0, plus and minus 4.5. And the asymptotes, which is b over a, is plus and minus 4.5 over 4x. Another example. In this case, a graph is given. So we will identify its standard equation. Take note, the hyperbola is sketched at the top and sketched at the bottom. So therefore, it is vertical hyperbola. Now, from the center going to the vertex, the value is 3. And from the center going to one end of the co-vertex, it's denoted by 4. So A3, B4, the center is 0, 0, and it is vertical. So the standard equation would be y squared over 9 minus x squared over 16 equals 1. Now, what if the given hyperbola, the center is no longer the point of origin? What if it's already HK? Now, we will have this one. So the standard equation here, we will simply add h and k. Now, let's have the first example. At this point, the foci is located at -3, -1. So therefore, it's located here. The other foci is at 7 and -1. Take note, from -3 to 7, the distance there is 10. So get half of it to get the center. So count 5 from one end. So 1, 2, 3, 4, and 5. So this is where the center is, at 2 and -1. The conjugate axis is 6. So center to one co-vertex, that would be 3. So that would be 3 up and 3 down. Now take note, the foci, it's located at left and right, so therefore it's horizontal. The value for our C is 5. Now center to focus, while center to co-vertex or B is 3. To find A, we will simply substitute here. So that would be 25 minus 9, or get the square root of 16. So therefore our A is 4. From the center, count 4 points to the left and 4 points to the right to locate A. Now at this point, sketch the auxiliary rectangle. Connect the corners here with a straight line to sketch the asymptotic lines. So with this, draw a curve approaching the asymptotic lines both at the left and at the right side. So therefore, this is the sketch of our hyperbola. So take note, the center is located at 2, -1. The value for A is 4, and the value for our B is 3, and it is horizontal. So therefore, the standard equation is x minus 2 squared over 16 minus y plus 1 squared over 9 equals 1. Now, another example. In this case, the standard equation is given. Let's identify the coordinates of this one. Now, take note, x is subtracted, so basically it is a horizontal hyperbola. The value for A is 2, and the value for our B is 3. So to find C, we will simply substitute, and we will end up with square root of 13, or around 3.6. Take note, the center is located at +2 and +1. So let's sketch that one. The center is at 2, 1. The value for A is 2, so 2 to the right and 2 to the left. The value for B is 3, so 3 up and 3 down. The value for C is around 3.6. So from the center, 3.6 to the right, and 1, 2, 3.6 to the left. Okay, sketching the auxiliary rectangle and connecting the corners here with a straight line to sketch our asymptotic lines, and sketching the curve, we will have this one. So with this, the vertices, it's located at 0, 1 and 4, 1. The co-vertices is located at 2, 4 and 2, -2. The foci, it's located at -1.6 and 1, and the other one is 5.6 and 1. Well, the asymptotes is equal to, y is equal to 1 plus and minus 3/2 x minus 2. Now, how to convert general form of hyperbola to standard form or vice versa. Let's have an example. We have here the given general form of a hyperbola. So step 1 is to group all x term and all y term together and transfer 5 or the constant to the other side. So with this, we will simply factor out 2 here. So factor outing negative 2, we will have y squared. 4 by negative 2, we will have negative 2y. So next to this is we will complete the square. Half of 6 is 3 square, that is 9. Half of 2 is 1 square, that is 1. So therefore, we add 9 here. We also add 9 to the other side. We added 1, so add 1, but multiply it with the term outside here, which is negative 2. So at this point, we write this to binomial 4. Square root of x squared is x. Square root of 9 is 3. Then sign of the second term is positive, then square. Minus 2. So square root of y squared is 1. Square root of 1 is 1. Sign of the second term here, or linear term, is negative, then square. Is equal to negative 5 plus 9 minus 2. We will end up with 2. Now take note, for hyperbola, it should be equated to 1. So therefore, divide the entire equation by 2. So we will end up with this. So 2 over 2 is 1. At this point, we canceled 2. So therefore, this is the standard equation of the hyperbola, which is its equivalent in standard form is this one. Now, we will counter check. This time, we will reverse. We will have the standard equation first, then we will go back to the general form. Now, to do this, is we will expand this one. So, squaring a binomial, square the first, multiply the first and the second term times 2, and square the second. So, the same thing here. Square the first, multiply the first and the second times 2, and square the second. Now, at this point, so subtract these two terms here. So to do that, you simply cross multiply. So 1 times the term here and 2 times the term here. So it's minus 2. Then 2 times 1, we will end up with 2. So eliminate 2 by multiplying 2 to both sides. So we will have x squared plus 6x plus 9 minus 2y. Negative 2 times negative 2 is positive 4y. Negative 2 times 1 is negative 2, and 2 times 1 is 2. Now at this point, group all x and y terms at the left and transfer 2 to the left side as well and equate to 0. So with this, we will end up with x squared plus 6x minus 2y squared plus 4y. 9 minus 2 minus 2, we will end up with 5, which is exactly the same with the original given. So that's how are you going to convert from general to standard or standard to general form. Thank you.